Hey everybody, Joe here. I want to check out a puzzle today by GDC. It is called Big Zipper Islands. And the rules today are normal Sudoku rules apply. That is 1 to 9 in every row, column, and 3 by 3 box. Modified Nurikabe is draw 8 lines of length 2 or more, such that each circle is the center of one of these lines. Each circle will be the center of one of these lines. All right, we do have 8 circles. Each will have its own line. The lines only move orthogonally and may not touch themselves or each other orthogonally. Each 2 by 2 must contain at least one cell on a line. Non-line cells form a single orthogonally connected area. Zipper islands, digits in equal distance to the circled center of a line, sum to its central digit. Partial Suguru, digits never repeat on lines. Circles marked with S also count the number of cells on their line. I have 3 of those. Ambiguous cave is a digit in a diamond, is of either type, line or non-line, and counts how many cells of its own type it sees in the row and column combined, including itself. The other types block vision. Okay, those are all of the rules. So every circle will have its own line and they cannot touch each other. So this one is going to be a corner, more or less, and it will be the center of a line. So if it goes that way, it must go this way. So there won't be any that are 2. There'll always be an odd number, because if they move one way, they must move the opposite way. Or if they move on one side, they'll have to move on the other side. But this one is also in a corner. And now this one is as well in its own corner. This one cannot go down because it cannot touch orthogonally. It cannot go over, so it is now in its own little corner. These 2 are in a corner because they are diagonal of one of each other. I don't want these black, I don't think. This one cannot go over this way, so it will have to go down, therefore have to go up. This little area cannot be a line, so it will be part of the, what was it called? Well, non-line cells form a single orthogonally connected area. So it'll have to get out. This one is also in a trapped little area, so it will have to keep going that way. This is trapped here as well. Actually, I can mark all of these that cannot be a line. These two, that one, that one, that one. All of those cannot be a line. And I can start drawing them out. So that has to go out. This area up here is going to have to get out over this way. Because as you can see now, even if it's all being trapped so far. So this is its only passage out. That cannot be, neither can that. This is its only passage out, but also it needs to get up to this corner eventually. So this, because it can't go, it's not touching there, it must touch orthogonally. This is its only passage to the rest. So this will need to be as well. And then that will need to be also. Now this one cannot be a 2x2. So we went down 2 there. So this side must go 2 more. We just went 1. So it's either going to be there or there. And either way that goes is going to make that yellow. As in, if it goes up, no line can be there. If it goes over, no line can be there. Let me get those circles out of there. But these will go one more time. And this diamond a digit in a diamond is of either type, line or non-line. It counts how many cells of its own type it sees in the row and column combined, including itself. So it's getting one more, which will be visible either way it goes. So it sees 1, 2, 3, 4, 5. It will see 6. So it must be 6. This one will be 4 or 5. This one will be 2, 3, or 4, depending on if it goes over that way. Oh, this one here is done. it can't go out this way because then it will not be able to have a central digit. So that is yellow. Did any others do that? Not yet. This one at the moment it is 4, but it can go all the way up to 6. If this red line was to come down, it would have to go there. And then that and that and that and that and that would all be yellow. But then that would be a line. So that would have to be yellow. And that would be a 2x2 box of yellow. Let me see. If that goes down, that goes over. That, then that would be yellow. That would be yellow. That would be yellow. That would have to be yellow. That would have to be a line, so that would be yellow. And this is trapped at the moment. So it would have to go there and be a 2x2. So that does not do that. And since it does not do that, those are yellow. And now we cannot have a 2x2 there. So that is that one's 6th, or that's the total line there. So this one is now yellow. And now we're about to make a 2x2 here. So that one must have one more on that side because we added one to that side. So now this needs out. That one could get one more though, I guess. So it may not be done. But this side, it is true that that needs out. So it will go to there, at least. This could get one more. Oh, this one has an S in it. So it is 3. A digit, circles marked with an S also count the number of cells on their line. So that will either be 5 or 7. This one is 7. I'm still in a normal Sudoku. I'm just gonna darken these. For my own visibility. Okay. So this one either oh, okay. If this one goes up, if this one goes up, it is 5. Oh wait, that wouldn't have to be a 5 though, because that is not an S. Never mind that. These are 1-2 though, aren't they? That one is a 6. So this one must be a 1 because they will equal the central digit. We'll also have a 5-2 and a 4-3 somewhere. So basically all of these are 2, 3, 4, 5. And then, we have a quadruple there, so these are going to be 8, 9. Okay. This one is yellow. If this one... Alright, this one cannot stop here. Because if it does, that has to be yellow. Oh. Alright. If this one stops here, then that would have to be a line. And it would have to be this one's line. And then this section up here would be trapped. So this cannot be yellow. It must be line. And it must belong to that one. So it has to grow one more. And it can't grow one more, or else it would have to trap that yellow box in completely. So that is where it stops. And now we have a 2x2 there about to happen. So this side needs one more. And that's where it is forced to stop. So that will be yellow. This one now needs out. This one will need out again. This one needs to come on up, attaching it to its friends. So far, we'll have something down here avoiding 2x2s and attaching in one of these spots somewhere. Okay, so this one is 4 at the moment, but it could get more. This one is no longer able to be 3. It will be 2 if it yellows here, 4 if it yellows here. This one is trapped though now. So that is where that stops. Because if it grew one on this side, it would have to grow one on this side, and it cannot. So that is indeed 4. Now this one should be 5 or 6. It is done. 1, 2, 3, 4, 5, 6. It sees 6 yellow. So there will be a 6 down here. 1, 2, 3, 6, and 7 with a 4 or 5 are in there somewhere. This, that can still be anything. Oh, we're about to make a 2 by 2 over here now. So that has to go like that, and now it stops because it cannot grow anymore on that top side. Now we're about to make a 2 by 2 there, so that will be a line. This is the center of said line. So I think it must go like that. I think that's the only way that will work. The circle has to be the center. But this is about to make a 2 by 2, so it has to be a line there. So that should complete all of that. That yellow connects there. This should be one full region of orthogonally connected area. And it is. So now this is going to be a 2. This is going to be 3. This is going to be 4. We'll have a we have a 4, 5 here. So we will have a 2 or 3 there. There's going to be a 4 up here. This line cannot have a 3 on it. Um, this sees a lot of numbers. This sees 3, 4, 7. It's not going to be 2 either. So this is what? 5, 6, 8, 9. Can't be 5 though, because it can't have a 3 on it anywhere. Oh wait, could it be 4, 1? But 2 times. It would have to be 4 here and 1 there. 1 there and 4 there. That could work. It could be 5. If it was 6, it could be 2, 4. 5, 1 would still work as well. It could be 5, 1 in both spots, maybe. 5 here, 1 here, 1 there, 5 there. That would work as well. Okay, maybe a different line. What about this one? If it was 5. Four, 1, 4, 1. Maybe. Um, any more on 6s perhaps? Oh, this one is known. Now it is a 4. Sees 4 yellow. So now this must be the 4. And now that must be 4. 4 goes with 3. And 2 goes with 5. So that all looks good. 1, 2, 3, 4. This will be 5, 6, 7. Which makes a triple in this row. 4 at the end will be, this cannot be 3, so it will be 1, making this 5. That one will be 2, 1 now. There's going to be a 1 over here. The 5 will be up here now. And this one, it could still be 4, 1 that way, or 2, 3 that way. This side cannot be the 3 because of that one. Oh, this one also had to be a 5 just because it was 5 lines. I overlooked that S. But it still got there. That one cannot be a 5 now. Can it still be a 6? It would have, this cannot be a 5 or 1. So it would have to be a 2. This would have to be a 4. So that cannot be, ooh, what about 3? Well, it can't be a 3, 3 either. I didn't think about that. I haven't had an even number though, so. But that cannot be a 6 now. I have to be careful with that though, because if they're in different cages, it could be an even number and be the same odd number totaling it. So that is a high, 8 or 9. If this is 6, then that would have to be 7, 8, or 9. No big deal there. This cannot be 2, 3, 4, or 5. Can be 1. Oh no, it cannot be 1. Because that would be 3, and then these would also have to be 1 and 2. So this cannot be 1, 2, 3, 4, or 5. This is 6 or 7 only, making this one an 8 or 9. And if it was 6, then this would have to be 5, 3. 7, if it was 7. This would not be able to be 8, 1. It could be 6, 3. But a 3 goes down here, doesn't it? If it's 6, it's 8. It would not be able to be 7, 1. It would have to be 5, 3. And if it was 7, being 9, it would not be able to be 8, 1 or 5, 4. So it would have to be 6, 3. But regardless, 3 is down there with 5 or 6. But it also puts 3 up here, and we already have a 3 in column 3. So that is 3. A 2 will be over here. If a 2 goes here, that will be 6 or 7, which is fine. Is there anything else? There's a 5 here. 5 here. Would not go with 3, but it could go with 4 though. It would make that a 3, 2. So that might be alright still. If this was 5, 4, that could be 2, 7. Okay, that might be alright. This cannot be 1, 2, 3, 4, 5, 6, 7, 8, 9. It would not be 6 though, because 5, 1 is in both of these. And we cannot use 4, 2 twice. And we cannot use 3, 3 because it's in the same 3 by 3 Sudoku. So that is 7, 8, or 9. This cannot be 1, 2, 4, or 5. This can be 3, 6, 7, even 8, I guess. So quite a lot there. But it does give me some stuff here. It can be 1, 2 would work, 3 would work, 4 does not, can't be 5. It could be 6 though, but that is all. This one has to be 5 or higher. 5, 6, 7, 8, which would make this cannot be 1. 2 would work for 7 or 6 or 5. 3. It cannot be 6 though. Now, seeing as how this is 2 or 3 only, this cannot be 8. Could be 7 still, if it was 2. Okay, so that looks all good at the moment. Red lines will never have a 9 on them though. Would that help me out anywhere? Well, they could if it was in the circle, obviously, but nowhere else, I mean. So there is a 9 down here, a 9 up here, or maybe there. Maybe no help with that yet. Maybe Sudoku. Three. A 3 cannot go here because we would have 3 1 2s. So it goes there or there. If it did go here, it could not be 1, could not be 2, 3, 4. Could be a 5 here, making 8. That would be the only thing it could be. 3, 5, 8. Otherwise, it will have to go there. That does seem okay though. If this was 3, it would put the 5 there. Guess that would be alright. That would be alright as well. 6, 7 is making a combo, taking 6 out of there. So it should take something out over here. It'll take the 3 out. Still be 3 though. Alright, let me keep going with... Where was I on Sudoku? I was on 3, 4... 4 can still go there if that was 5. I have all the diamonds, yeah. Move on to 5s. 6s. 7s. Don't have many 7s. Oh, neither one of these. Oh no, that's not true. This one could be a 7. 7 goes in one of those. Can a 7 go down here? A 7 cannot go on the bottom. It would have to go 7-1 or 7-2. So a 7 does go in here. And down here. So if this was a 2, it could still be a 6 though. If this was a 6, it would be there. It would have to go there because it wouldn't add to itself to make a 12. It'd have to be in one of those. It would be in that one. Yeah, that would be okay. That would be a 7. That would be a 6. Oh, and then 6 would have to go down here. Because we know 3 does. So, so if that was 6, let me double check again. If that is 6, I do believe it can't be that one. Because like I was saying, it would make 12. So it would have to be there. That would have to be a 7. We know the 3 goes down here, and we would need another 6, so that would be broken. So, and it can't go here, because that would be a 2 or a 3. It can't go here, though. Oh, that's kind of a bummer. Ah, but 6 cannot go here, because that would have to be a 2 or a 3. But that's not giving me anything definite, is it? 6 cannot go on this row. It can go there or there. Hmm. I don't think that's quite enough yet. If it goes here, though, actually, it does go in one of these two, doesn't it? Because if this is a 6, then obviously it's a 6. But if it's a 7, then 6 is down here. So it is true to say that 6 is in the bottom two rows. And it's true to say that 6 cannot go here, because that would be a 2 or a 3. So it will be in the bottom two rows, which means it must be in the top row, in the middle 3 by 3, and that is the only spot it can go. And this will now be 6 in one of those. What? Let me just mark everything here. It can be a 2, we know. It cannot be a 6. It can still be an 8, though. It has 2 or 8. And this was unable to be a 6. So it is just 1 or 7. And we know it cannot be 7. So this must be a 1. And this must be 8. And this must be 9. And now 5 would still work with 4. Actually, let me check this side. It can be a... No, it cannot be an 8. So it cannot be 1, 2, 3. It could be 4. Cannot be 6. Cannot be 7. It cannot be 8. Because 1 is in this column. So this will be 4, making this side 5. Turn that into a 3 and a 2. 3 is now here because of Sudoku. Above and below it. 4 is over here. This one is no longer 3. 1 or 2. That would still be... That didn't take anything out on that side. But it did put a 3 at the top. And this is the only spot a 3 can go. So this can no longer be 7. It can still be 5 or 6, however. If it was 6, that would be okay. If it was 5, that would be okay as well. Can still make 2 8s there. Alright, it's probably time for more Sudoku. What's left over here? There has to be a 1 up here. This needs a 2, doesn't it? That can only be a 2. It's right there. It cannot be in any of those, obviously. So 2 will go down here. Oh, also, since we got the 8, we could have... I just overlooked that as well. Let's see. This could be a 6. What's left in this box? 6 and 9. Which is giving me a combo pointing here, making that 7. And now 6 will go with 3 down here. This will no longer be 7. That will still be 8 or 9. That's the only one that changed again. So 3, 6, there will be an 8. There has to be an 8 down here, so that is 9. Oh, I mean, I already knew that was 9 because it's 7 too. And this will be with 8 and 5. This side will have 5 and 4. So this must be an 8. Three cannot be in the circle. Because we would have 3 1 2s again. So it must go there because that one is seeing the central box. The central digit, rather. 3 must be on this side now. That is the only spot it can go. So that makes that a 6, which makes this a 5, which makes this an 8. It could be 7 1 or 6 2 still. But we do get a 1 here, and now it cannot. So that will be 2, that will be 6. I will put 6 there. It'll put 2 right there. 6 now goes there. So this will be a 7, 8, or 9. And it's on the far side. So this will be a 1, 2, or 3. And it can only be 1. 2 and 3 are already in the 3 by 3. Obviously 4 would make it too big. So now this is 7. If this was 1, it would have to have another 6. So the 1 must go here by Sudoku. And what else makes 7? Can only be 5, 2. Because the 4, 3 is right there. So this one must be 2 because of that 2. And this one will be 5. Now 5 goes right here. Four will be in one of those. This 3 by 3 has 8 and 9 left. 9 must go there then. 8 there. And this is probably running out of option. 1, 2, 3, 4, 5, 6. It is 7 or 9. If it was 7, it would have to be 6, 1, and there are already, both rows already have a 6. So it must be 9. And I see 4 there, so it cannot be 5, 4. It cannot be 6, 3. It cannot be 7, 2. So it must be 8, 1. It's going to put a 9 in that column. This top one up here is a 7 or 8. There's already an 8 in the row. So that will do that. And now this must be a 9. That's all that was left for the row. This will go with a 8. Or 8, so this will be a 5 or 7, and it can only be 5. That is now 7, that is 5. Over here with the 4, we have 7. So that will be a 9. Which makes this a 9, 8. Which does that one. This row, or this box only has one number, 7. 7 will go here. And the rest will be unfolded. That was a very nice puzzle. I did enjoy that. Making the maze there with the Nurikabe addition. Making the little islands. That was a nice touch. Yeah, very nice puzzle. That was Big Zipper Islands by GDC. There will be a link below if you want to check it out. Give it a go and a like. And like and subscribe if you enjoy it. Thank you so much for watching and have a great day. Bye bye.